Hi folks, happy snow day. We're going to finish off our arithmetic series work here. So yesterday we saw that we could find the sum of an arithmetic series with one of these two formulas that's up top here. We always needed to know u1 and n. So we'll just keep going on the handout for the notes. Example 2, we didn't have n, so we had to go ahead and find it. And we'll do a couple of other examples and then just assign a little practice. So here we have a summation. And let's imagine that this is happening on paper 1. So you don't have access to your calculator. You can't just type it in as the sum from k equals 1 to 20 of 3 plus 4k. The idea of a sigma notation is that you sub in values of k from 1 up to 20. Now, think about that. That's going to be really painful. It's going to be a lot of numbers. Let's just do the first few. So if I put in 1 for k, I would get 7. If I put in 2 for k, I would get 11. If I put in 3 for k, I would end up getting 15. Okay. And I could even do the last one. I could put in 20 for k, and I'd figure out that that's going to be 4 times 20, which is 80, plus 3, so 83. So I have all these terms that I'm going to add together. Okay? And to do it by hand is really, really tedious. Now, if I write out the first few terms, I might notice something. 7, 11, 15 is an arithmetic sequence. It's arithmetic where the first term is 7, okay, where the common difference is 4. We know that over here, this would be our last term in the sequence. un, or u20, is 83. And we also know the number of terms in this series. We're going to go from k equals 1 to k equals 20, so there are actually 20 terms. Okay, we don't see them all. We see the first, the second, the third, and then we go all the way up to the 20th. Once we recognize this as an arithmetic sequence, it becomes a whole lot easier to deal with. We have our two different series formulas if we want to find the sum. There's this one, okay, or there's this one. And given what we know, we can use either one. Okay, so if you hadn't bothered to find the 20th term, which might have been a bit of a pain, then you probably would be using this one on the right. If you did bother to find the last term, it's probably easier to use this one on the left. So we'll work it through either way. But notice here, it's asking us to find the sum from k equals 1 to 20, so that's why it's 20 terms. So S20 will be 20 over 2. U1, which is 7, plus un, or the last term, which is 83. Okay, the numbers look horrible, but let's see. 20 over 2 is 10. 7 plus 83 is 90. So we actually end up with pretty easy stuff to do without a calculator. 10 times 90 is 900. What if we did it with the other formula? Well, let's just take a quick look. If we did it with the other formula, we'd say S20 is n over 2, so 20 over 2. 2 times u1, which would be 7. N minus 1, so n is 20 here, so n minus 1 would be 19. And the common difference is 4. Okay, let's make sure that we get the same result. So this is going to be 10. 14 plus 19 times 4. Well, let's see. 20 times 4 is 80. 4 less would be 76. Ten times 90, or same result, 900. So the big idea here is if you run into some sigma notation that involves a lot of terms, probably the plan is going to be to see if you've got a pattern. So write out the first few terms and see if you can characterize it as either arithmetic or geometric. For now, we only know how to add up arithmetic sequences, but of course, very soon we'll move on to geometric ones. Let's put some of this in context with a word problem. So a new social media site is increasing its membership. In its first month, it had 20,000 new subscribers. So that means by the end of the month, it reached 20,000 new subscribers. In its second month, it had 40,000 new subscribers. In its third month, it had 60,000 new subscribers. So the new subscribers looks like this: 20,000 by the end of the first month, 40,000 by the end of the next month. Okay, 60,000. These aren't total subscribers. These are new ones. Assume the trend continues. Okay, so let's see. What do we know? We know that U1 here is 20,000. And we know it's arithmetic. It's going up by 20,000 each month. So the difference is also 20,000. How many new subscribers will there be in the 7th month? So how many new subscribers? Is that going to be U7 or S7? It's just going to be the 7th term in this sequence. Okay? That's what we're looking for. We want. So think about our different formulas. Here's the one for a specific term in a sequence. If we want U7, then n is 7. Okay? So U7 would be U1, which is 20,000, plus n minus 1, so that's 7 minus 1, which is 6, times the common difference, which is also 20,000. Now, you could probably have just added these up or written out the sequence up to the 7th term. That's not a big deal. So we end up with, let's see, 120 plus 20, so 140,000 new subscribers in the 7th month. Now here it says, how many subscribers will there be in the 7th month? That means the new subscribers from the 1st month plus the new subscribers in the 2nd month plus the new subscribers in the 3rd month, okay, all the way up to the new subscribers that appear in the 7th month. Okay. So really what we're doing here is we're going U1 plus U2 plus U3 and so on, all the way up to plus U7. In other words, we're finding the sum of a series. And again, you can take your pick of which series formula that you want to use. Here, since we know the last term, it's probably easier to use this one. But it doesn't matter which one you choose. We know D as well, so we could use the other one. Okay. So this will be S7 is 7 over 2 U1 plus UN, or U7 in this case, the last term. And at that point, I'll probably just go to my calculator. I might do some of it in my head. So 7 divided by 2 is 3.5. Okay. Times 20,000 plus 140,000 is 160,000. And it tells me that I should have 560,000 subscribers in total. Okay, and that kind of makes sense. They've been going up and up more and more every month. We might be interested in what month the total number of subscribers reaches 1 million. Okay, so let's take a look here. If the total subscribers, total is usually a word that makes us think of SN. Okay. And we're wondering, when does that SN reach 1 million? Now, here we wouldn't know what UN is in this case. I think we're probably going to have to use something like this, our other arithmetic series formula. Okay. Because the gag is, as long as we know all but one of the values, we can find the missing one. Okay. So SN here would be 1 million. N over 2. We're wondering what n is, or how many months or terms we'll deal with. 2 by 20,000 plus n minus 1 times d, which is also 20,000. Now once we've got the equation, I could just plug it into the calculator like that, and maybe I'd make fewer silly mistakes. Let's see, I'm going to need more space. So if I do want to make it a little easier to work with, maybe I'll times both sides by 2 to get rid of my fraction. Okay, and that means I'll just have a regular n here. think about what's happening in these square brackets. I'd have 40,000 plus 20,000n minus 20,000. And this becomes a little bit finicky to make sure that we do everything properly. At a certain point, I hope you're thinking, oh, why don't we just do this graphically? Yeah, that's probably a good idea. And if you're going to do it graphically, then don't do any of this nonsense. Just go straight to the graphical method from pretty much your first step. Okay, so I'm multiplying out here. Again, the real math in this question's already been done. We set Sn equal to 1,000,000, and we're solving for n. Okay, I'm going to move over some stuff here. I'm just going to write this in descending powers of n. Now, you might notice at this point a common factor you could take out. You could take out 20,000, and that would make the whole thing way easier to deal with. Okay, that would be n squared plus n minus 100, because 20,000 times 100 is 2,000,000. Okay. And again, if you're getting lost on the analytical steps here, just go straight to a graphical method. Okay, and then we go to the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, all over 2a, all over 2a, all over 2a. Okay, so take my word here. That's 401. That we're taking the square root of. Okay, all over 2. If I did the negative, I'd end up with a negative n value, which doesn't make any sense at all. So why don't I just do the positive one of these, which would be negative 1 plus root 401 over 2. Okay. So negative 1 plus root 401, which is just a little bigger than 20, divided by 2, gives me 9.51. Now, just in terms of interpretation here, if we were at n equals 9, that would be the end of the 9th month. These probably should be written to say that by the end of the first month you have 20,000 new subscribers. By the end of the second month you have 40,000 new subscribers. So an n of 9 is not going to do it. Okay, it's going to need n of 10 or in the 10th month. We will reach 1,000,000. Okay. So that gets us to the end here. I'm going to go through solving this graphically just so we know how to approach it. But if you are pretty sure you know what's going on there, you could skip straight to the work, which is outlined right here and is also on your little handout. Okay, so graphical approaches, I would go basically to the original equation. Okay, I would put in 1,000,000 on one side, 1, 2, 3, 1, 2, 3. And on the other side, I'm going to put in n over 2, so that's x over 2. And then I'll go brackets. Now the 2 times 20,000, I might do that myself. So 2 times 20,000 is 40,000. 1, 2, 3. And then I'd have plus n minus 1, so that's x minus 1, okay, times 20,000. 1, 2, 3. And you could clean this up yourself if you want, or you can leave it just as it is. So let's check out that that right-hand side of the equation. Sorry, I'm trying to get it to actually show up here. So I've got x over 2. 2 times 20,000, that's 40,000, plus n minus 1, I've got that as x minus 1, plus 20,000. Okay, now the last thing I have to think about is my window settings. This first equation, that is a horizontal line at 1,000,000. So I need to see at least up to 1,000,000 in my y's. As far as the x's go, that's the number of terms. Now, we actually know now that we're at under 10 terms that we need. But you could think about it, maybe a year is what you want to look at, so 12 months, or maybe you want to look at 15 months. You definitely don't want to look at a million months. You want to look at over a million for your y values, because that first equation is a horizontal line at a million. And so I'm doing something bad here. I don't want x min of a million. I want x min of 0. I want y max over a million. 1, 2, 3. There we go. I also don't need to see negative y values, so I could change that. X max, maybe I want to look at the first 15 months. I'll graph it. And look at this. My point of intersection is going to be the solution. Okay, 9.51, the same way we did over here. A little less fussy, okay, but the same answer. N is 9.51-ish. In the 10th month, it'll reach a million. You'll also get a negative answer, but that makes no sense in the context of this question. So there you have it. That's the end of sequences and series. The main thing here is that there are two different formulas for arithmetic sequences, for arithmetic series, and that you use whichever one corresponds to what you know in the question. All right, see you tomorrow, folks.